Very good morning and very good evening and good afternoon for the colleagues who's on the other side of the world. So myself, Thyagu, I'm part of Valio. So I'm a certified LabVIEW developer and I have close to 10 years of experience in LabVIEW development, and I've successfully deployed various test systems across US and Europe, currently associated with Valio India. And we are developing hills and tools for our ADAS feature developments as such, and for ADAS as well. A quick glance on Valio. So Valio is one of the world's leading suppliers for automotive, and we are into electrification, ADAS, acceleration, lighting, and interior experience. So these are the worldwide rankings, and I'm part of a division called driving assistance. Today's topic is all about building a robust application with LabVIEW Actor Framework. The introduction is that basically what is an actor framework? So actor framework is basically a software library that supports application development, where the VA or the actor can run independently and communicate with each other using messaging concepts. Is what we call it as an actor framework. So why to choose an actor framework for your software development is that actor framework by itself is a robust framework, where robust I mean like for a variety of reasons, like encapsulation, modularity, scalability, and maintainability, and various other aspects as such. So we would be discussing more on the scalability part, where an actor framework can come hand in hand whenever there is a change in requirements, or whenever there is a larger application development that is being initiated or being kicked off. Is what I call. So Akhil, I think the sessions would be recorded by itself and can be shared over the Google or the YouTube channel of GLA Summit, is what I can understand. So I'm not sure if we can record it or not. So I'll get back to the topic again. So in this particular aspect of scalability, so since the framework is actually designed to run by independently, the ability to scale or to the ability to elastify itself is hugely enormous. As such, it is highly adaptive to any requirement changes which we see on a day-to-day basis, or in any software development life cycle as such. I mean, we would have often seen where there are a set of requirements which is kicked off at the moment whenever we develop a software application, and often we see ourselves doing that kickoff, and then get the detailed requirement documents, and then we start the application development as such. But we have seen ourselves during on the entire development life cycle, where there will be a change which would be incorporated, or there would be a scenario where the client would be requesting a change during or somewhere in the middle of the development cycle, which would eventually change the entire architecture, or which would eventually affect the entire architecture, is what I feel. But in this case, where an actor framework is chosen as the base architecture, any changes on the mid level of the development, or in the software development lifecycle, can be accommodated easily, is what I would like to feel, or I would like to convey at this point, or to the forum here. So I'd like to give a demo where I would like to call the application A. I mean, I would like to say this application is called as application A, where it is a simple application which would usually perform a single application for the demo purpose. So adding an input A and B is what the overall application requirement is all about. So to accommodate our requirements, so I'm creating an actor framework, the entire actor framework, where event actor would be the base actor, which uses user events to generate or to communicate between the actors. And the UI actor is basically a interface actor, which would be showed to the user to interact or to give the inputs to the application itself, and then the tester module or the module which would be actually performing these action which is requested by the user. So this is the overall application requirement. So as I said, like we have three actors. One is the event actor, which should be the base actor, and then there is an UI actor, which would be used as an interface where all the users are where the users can input their requirements. In this case, it's going to be adding A and B is what I've given as an operation, and then there is a tester module where the tester module would perform this operation. So basically, adding the inputs A and B and giving the result back to the UI user is what I've done. So this would be the overall architecture would look like. So the event actor and then the UI actor, and then the UI actor would initialize a tester module. The tester module would then perform this operation which I've requested by the UI actor, and then sends back the result as a message to the UI actor. I'll stop my screen for a minute to show the demo. So in this case, I'm using so this is the UI actor where I'm inputting an input called 23, and then the sorry, and then the feature which I'm trying to do is basically an addition with a number called 54, and then when I click the start or do the calculation, it gives me the results back again. So this is exactly what the demo application which I've created. So let's call this as an initial set of requirements, and then we have a set of application B, which is called as the new requirements. So let us assume that we during the entire development cycle there is a new requirement that came up where the customer is actually asking the user or the developer to accommodate multiple user events or multiple requests from the user, where they'll initiate multiple addition operations, and then the results has to be keyed back to the entire application. So let's assume that this is happening at the very end of the development cycle, where we have already freezed the application, and then we have already developed the entire architecture and then the functions as well. So it has been already almost freeze, and you're about in the stage of releasing it. But there is a new requirement that comes up where it is called as an application B, where the same application which you have developed to add only one function now have to do a multiple pairs of inputs for A and B, and then which would result in multiple outputs. So these kinds of changes is actually easily implementable. So the overall change that had happened for the entire module is very, very simple. So basically, what I've did on the architecture level is that, as you know, that I've already developed the tester module, which is called as tester module actor 1. So I'm basically nesting the tester modules, basically launching each tester modules on a standalone module, where each of them launched in parallel, and then will accept each or independent pairs of inputs, and then this can be calculated or computed in the background, or the tester module can run independently and then compute their own results, and then send back as a message. Sorry, I just missed to share the screen. Yeah, sorry about that. So I'll come back again. So yeah, so we have seen the demo on application A, where the initial set of requirements was to add 2 elements and then give the results back. So for that, we have created a event actor, and then that would be the base actor, and then the UI actor, which would act as an interface for the users to input the inputs, and then the tester module, which would be the actor, which would be actually doing the operations in the background. So we have seen the demo, and then now let's say at the very end of the or let's say we have reached a position where we are about to release the application A, and there is a slight change in the requirement where the client wants to add multiple user inputs to the same application, and then which would eventually result in a multiple outputs. So to accommodate this, let's assume that we have used an other frameworks which we have default and LabVIEW. So this would have a tedious process of updating all the other functions and then getting them on board to perform the same application to have multiple inputs. but these things can be easily achieved, or these kind of changes can be easily achieved in an actor framework, is what I'm trying to convey in this forum actually. So how did I achieve these multiple additions and eventually end up in a multiple outputs, is what I did was like simply nesting the tester modules with the individual pairs of inputs that the user client has given, and then creating them as a standalone modules. I mean, the nesting them would eventually create them as a standalone modules, and then send the each individual message to the UI actors, and then UI actor can actually show you the results actually. So I'll do the demo of this again. So let's assume this is the application B. I hope the screen is visible now as well. Yeah. So yeah, so I am adding this as addition, and then I'm adding one more input of addition, and then I'm asking to calculate. So this is what I've received. So I have received multiple pairs of inputs. So these are launched as an individual actor, and then these messages are sent back to the interface, where we'll have independent results as an outcome. Okay, so this is exactly what we're trying to do at the moment. I'll share my uh, presentation again, just a minute. Yeah, so this is exactly what we are trying to achieve with NI's or LabVIEW's actor framework. So this example might be a smaller one, or is a fraction, but I would like to show you the real-time use case which we have really deployed within our organization. Is like, so this would be the entire architecture which we have designed for our own use case, where we had an actor called orchestrator, which would be launching a actor called model handler. So this model, so I'll explain what is exactly what we are trying to do. So we, as you know, that every organization or every OEMs who are into ADAS, they're into capturing data, or they're into real world data capturing. So this is one of the applications which we built for our own use, where we are trying to validate the integrity of the data that is captured by our own vehicles. So this is one of the applications which we did, where we would be validating individual traces, like traces as such, sensor data from various sensors. So this is the application which would be validating individual sensor data, like for example, it can be a radar, it can be an ultrasonic data. So we have multiple sets of data, sensor stacks in a ADAS vehicle. So these testers would eventually be individual traces or individual data, which would be captured from individual or corresponding sensor data sets. So for achieving this application, we have designed an architecture one similar to what I'm showing on the screen now. So we have an orchestrator, which would be basically the overall handler, who will be taking care of all the other communications. So he'll be launching a module handler or actor called model handler. So model handler is basically what tester is made up of. So the model handler would eventually launch multiple testers. So these testers can initiate individual testing of individual traces or individual data sensors. So this is the overall architecture which we define for a real-time use case. And when I go to the next, I mean, so this is the actual requirement as such. So we have the sensor data that is coming into each individual testers. Each individual tester would be performing their own dedicated test steps, and then sends back the message or the test results to the model testers, and then the model testers consolidate the results to the model handler. The modular handler would then publish the testing results to the end user or the user itself. So this was the actual requirement. And then later in stage, there was a change where the client was requesting to add multiple vehicle data into a single application. So this application is actually was originally designed to handle one data set from one vehicle at a time. So, but now the requirement has been scaled so that there are multiple data from multiple vehicles which needs to be handled by the single application at one point in time. Meaning, at any point in time, this same application is supposed to run data from various vehicles at a given point in time. So this was the requirement change. So since we have already chosen Actor Framework as the base framework for developing this entire application, we were actually this was very easy to do these changes, or this was very effortless, I would say, in terms of having this huge requirement change to be incorporated into the existing architecture or into the existing framework. So what we have did to accommodate is that, so if you could compare, we have model handler and model tester. So the model handler is basically calling the testers to launch individual testers to validate individual sensor data from the car. But in this case, we have multiple cars which have multiple data. So here, what we are trying to do is that we are actually nesting the model handler itself. If you can see, actually, so the mouse, can you see my mouse pointer? I think you can see my mouse pointer, right? Yeah. So as you can see, the entire architecture remains the same. There is an orchestrator, and then there's a model handler which is performing all the test cases, or all the scheduling part. And then this model handler is again duplicated, or nested by itself, calling itself again. So this is basically an instance of model handler itself. But in this case, what I'm trying to do is that I'm calling the model handler itself as a 3 instance to handle 3 data from 3 cars. So so I'm calling that as sub model handler. So these 3 sub modeler will act as an individual application which would be testing the individual data from an individual car. So in this case, or in this way, we have achieved the entire use case of having this, or scaling the entire application to meet the requirements, is what I'm trying to convey here at this forum. So this is how the entire actor framework has keyed ourselves to scale to a bigger requirements, or whenever there is a requirement change, is what I feel. So I think that is the end of the session today. And if you have any questions, please feel forward to shoot it again. If there is no more question, I think we can close the session today. Thank you so much. And thanks, Christian, for the opportunity. Thank you so much GLA for Summit 2024. Thank you.